A very good afternoon, children. Welcome to our physics class. Today, let me discuss about vernier caliper and screw gauge. This is the picture of vernier caliper. Vernier caliper, what are the parts of vernier caliper? Inside measuring surface, inside measuring jaws. This is inside measuring jaws. This is lower jaw, that means outside measuring surface or outside measuring jaws. These two jaws is said to be fixed jaws. These two jaws is said to be movable jaw. This screw is called as a set screw. Then this is the slider. Then vernier graduation, the slider unit having vernier graduation. Then this screw is called as a thumb grip. Then this measurement is called as a main scale division. Then here this is depth bar, main scale graduation, then depth stand measuring, that means main scale reading. So once again repeat, inside jaws, outside jaws, vernier scale and main scale. Simply says these are the very important parts. Then this is picture of screw gauge. Screw gauge anvil. This is a U-shaped frame. Then this side screw is called anvil. Then this is the spindle. This is sleeve. Then thimble. This is ratchet. Here this screw is called as a movable screw. This is a fixed screw. This is stud, simply says stud. This is main scale reading. Here this is the main scale reading. Then this is a circular scale reading. Circular scale, that means 8 scale reading. Here this is called 8 scale reading. This is a pitch scale reading. PSR, short form PSR, HSR. PSR means pitch scale reading. This is 8 HSR. HSR means 8 scale reading. This is ratchet arrangement. So adjustable screw. So these are all the important parts of the vernier caliper and screw gauge. The next one, in our daily life, we use meter scale for measuring length. They are calibrated in centimeter and millimeter. So scales measurement having centimeter and millimeter. The smallest length which can be measured by meter scale is called least count. Least count means, so very important point, note it down. The smallest length which can be measured by meter scale is called least count. Usually the least count of the scale is 1 millimeter. Ordinary scale, least count of ordinary scale is 1 millimeter. We can measure the length of the object up to 1 millimeter accuracy with this scale. By using the vernier caliper, we can have an accuracy of 0.1 millimeter. Note it down. This is very important point. Vernier caliper, we can have an accuracy of 0.1 millimeter, and with the screw gauge we can have an accuracy of 0.01 millimeter. These 2 points is very important for your objective type question. Vernier caliper we can have an accuracy of 0.1 millimeter, and with the screw gauge we can have an accuracy of 0.01 millimeter. Then description of vernier caliper. Description, already we know the description, that means parts of vernier caliper. Once again repeat, vernier caliper consists of thin long steel scale graduated in centimeter. This is the thin long steel scale graduated in centimeter. Here this is a centimeter and millimeter, called main scale division. Main scale, this is a main scale. Here this is called main scale. To the left end of the main scale, to the left end of the main scale, here left end main scale, and upper and lower jaws, this is upper jaws, this is lower jaws, are fixed perpendicular to the bar. This bar perpendicular to this bar, that means upper and lower jaws, this is upper jaws, this is lower jaws, are fixed perpendicular here main scale ke perpendicular direction, perpendicular to the bar. These name are as fixed jaw. These name are as fixed jaws. To the right of the fixed jaws, a slider. This is a slider. Slider with an upper jaws. Slider with an upper and lower movable jaws is fixed. Movable jaws is fixed. Upper and lower movable jaws is fixed. The slider, this is the slider. Slider can be moved or fixed any one position. Use a screw. This screw. Use a screw. The vernier is marked on the slider. This is the vernier. This reading is called as a vernier. So vernier scale is marked on the slider, and it moves along with the movable jaws and the slider. The lower jaws, this lower jaws are used to measure external dimension, and the upper jaws, this is upper jaws, are used to measure the internal dimension of the objects. The thin bar attached, here this is the thin bar attached to the right side of the vernier scale is used to measure the depth of hollow objects. So these are all the important parts of vernier caliper. Next, uses of vernier caliper. What are the uses of vernier caliper? The first step in using the vernier caliper is to find out its least count, range and zero error. So what are the uses? Main important two uses: find out its least count, range and zero error. So what is mean by least count? Least count, this is very important. 2-mark question. Note it down, children. Least count. What is mean by least count? Least count of instrument. In short form, we say L dot, capital L dot C. LC. LC means least count. Least count is equal to value of one smallest main scale division. Here, one smallest main scale division. This is the one smallest main scale division. Value of one smallest main scale division divided by total number of vernier scale division. Here, this is the vernier scale division. So slider having a measurement unit. This reading is called as a vernier scale reading. So one smallest main scale division divided by total number of vernier scale division. Total number of vernier scale division means this is the total number of vernier scale division. Here, this line. So the formula, once again repeat the formula. Least count of instrument, LC, is equal to value of one smallest main scale division divided by total number of vernier scale division. The main scale division will be in centimeter, further divided into millimeter. the value of smallest main scale division is 1 millimeter. In the vernier scale, there will be 10 division. So here, vernier scale reading, there will be 10 division here, 10 division. So total number of vernier scale division is nothing but 10. One smallest main scale division is nothing but 1 millimeter. So least count is equal to 1 millimeter divided by 10 is equal to 0.1 millimeter. 1 divided by 10 is nothing but 0.1. Unit is millimeter. Converted into centimeter means is equal to 0.01 centimeter. So 0.1 divided by 10. It will automatically converted into centimeter. So 0.1 divided by 10 is nothing but 0.01 centimeter. So once again repeat the least count formula. Least count is nothing but value of, this is the main scale, value of one smallest main scale division divided by total number of vernier scale division is nothing but least count. One smallest main scale division is nothing but 1 millimeter. Total number of vernier scale division is nothing but 10. So 1 millimeter divided by 10 is nothing but 0.1 millimeter. It will convert it into centimeter means divided by 10. 0.1 divided by 10 is nothing but 0.01 centimeter. The next point uses is zero error. What is mean by zero error? Unscrew the slider and move it to the left. Here, this is the slider. Here, this is the slider. Move towards to the left. Touch with each other. This fixed jaws and movable jaws touch each other such that both the jaws touch each other. Check whether the zero marking of the main scale coincide with that of the zero of the vernier scale. So here, this is the vernier scale reading. This is a main scale reading. Main scale reading. These two zeros, that means vernier's zeroth reading of vernier and zeroth reading of main scale exactly coincide to each other means errors, if they coincide, then there is no zero error. So instrument having there is no zero error. Both the zeroth lines are coincide to each other, exactly coincide to each other means there is no zero error. They do not coincide with each other. These two lines are do not coincide. Here this picture is positive error picture. This is not coincide to each other. They do not coincide to each other with each other. The instrument is said to be possess zero error. So zero error may be positive or negative. Please note it down. This important point. If they coincide, then there is no zero error. If they do not coincide with each other, here do not coincide to each other, the instrument is said to be possess zero error. There are two kinds of zero error. Zero error may be positive or negative error. If the zero of a vernier is shifted to the right of main scale is called positive error. So this is the zero error, positive zero error picture. Zero, if the zero of the vernier, this is the zero of the vernier, is shifted to the right, here, right hand side from this zero, from this main scale zero, this vernier scale zero uh, shifted to the right of the main scale, it is said to be positive error. On the other hand, maybe the vernier zero reading shifted towards to shifted to the left side of main scale means negative error. So on the others, and if the zero of the vernier is shifted to the left of the zero of the main scale, then the error is called negative error. Here shifted to the left side of the zeroth reading of main scale, so error is said to be negative zero error. Now I am going to explain positive zero error with this diagram. Positive zero error. From the figure, you can see that zero of the vernier scale is shifted to the right of the zero. Here, vernier. Zero of the vernier scale is shifted to the right of the main scale. In this case, reading will be more than the actual reading. More than the actual reading. Hence, this error should be corrected. In order to correct this error, find out vernier division is coinciding with any one of the main scale. Any one of the main scale. Vernier scale reading. Any one of the vernier scale reading exactly coincide with the main scale reading. So, find out with vernier division is coincide with any one of the main scale division. Here fifth vernier division, here this is the fifth vernier division is coinciding with the main scale division. So positive error formula, please note it down children, this is very important formula for the positive zero error. So the positive error, so fifth line only exactly coincide with the main scale reading. Vernier scale fifth line reading only exactly coincide with the main scale reading. So the formula is, positive error formula is plus 5 into LC. LC means least count. What is the value of least count? 0.01. So plus 5 into 0.01 is equal to 0.05 centimeter. 0.05 centimeter, and the zero correction is negative. Zero correction is negative. But the error called as positive zero error. When we correct this error means is called zero correction is negative. Hence zero correction is minus 0.05 centimeter. So இந்த இடத்துல 5 என்றது exactly coincide. So yes, error positive error plus 5 into 0.01 centimeter, that is nothing but least count. So the value is 0.05 centimeter. அப்போ இங்க ரைட் ஹேண்ட் சைடில் மூவ் ஆனதுனால இந்த ரீடிங் ரைட் ஹேண்டில் ஹையராக போனதுனால இதை சப்ராக்ட் பண்ணியாச்சுன்னா ஆட்டோமேட்டிக்கலி ஜீரோவும் மெயின் வெர்னியர் ஸ்கேல் ரீடிங் ஜீரோ தென் மெயின் ஸ்கேல் ரீடிங் ஜீரோவும் எக்ஸாக்ட்லி என்ன ஆகிடும், கோயின்சைடும். அதனால எரர் பாசிட்டிவ் ஆனதுனால வேல்யூவை சப்ராக்ட் பண்ணும், தட் மீன்ஸ் மைனஸ் பண்ணும், தட் மீன்ஸ் நெகட்டிவ். நெகட்டிவ்னா மைனஸ் பண்ணும், மைனஸ் 0.05 சென்டிமீட்டர் வர ரீடிங்லேருந்து எரர் வேல்யூ மைனஸ் பண்ணியாச்சுன்னா ஆட்டோமேட்டிக்கலி correct this positive zero error. So once again repeat the formula. So positive zero error is equal to plus 5 into least count. That means plus 5 into 0.01 is equal to 0.05 centimeter, and the zero correction is negative. Hence zero correction is minus 0.05 centimeter. Then next, negative zero error. Already we know the statement of negative zero error. Zeroth reading of vernier scale shifted left hand side of the main scale, zeroth line of main scale reading. So error is called as a negative zero error. So here you can see that the zero of the vernier scale is shifted to the left side of the main scale. So the obtained reading will be less than the value actual reading. So to correct this error, we should first find out the vernier division is coincide with the which line of the vernier lines exactly coincide with the main scale reading. Here I think the fourth line, so exactly coincide with the fourth line, exactly coincide with the main scale division. So is coincide with any of the main scale division. We found in the previous case. In this case you can see that sixth line is coinciding. Maybe the sixth line is coinciding. To find the negative error, we can count backward from 10. Backward from 10. Here the fourth line is coinciding. Fourth line is coinciding. Here 1 2 3 4. Here fourth line is coincide. 1 2 3 4. Fourth line is coincide from the reading 10. So therefore negative 0 error. What is the formula of negative 0 error? Minus 4 into LC. That means minus 4 into 0.01 centimeter. What is the answer? Minus 0.04 centimeter. Then 0 correction is positive. Why? Because the reading of zeroth reading of the vernier scale shifted to the left hand side. முன்னாடியே போயிடுச்சா? அப்ப ரீடிங் உடைய வேல்யூ எல்லாம் என்ன இருக்கும்? பிஃபோரா இருக்கும். சோ அதுல இருந்து என்ன பண்ணணும்? ஆட் பண்ணீங்கன்னா எக்ஸாக்ட்லி என்ன ஆயிடும்? கோயின்சைட் ஆயிடும். So the zero correction is positive. Hence the zero correction is plus 0.04 centimeter. Here minus வேல்யூல 0 எரர் வந்துச்சுன்னா அந்த வேல்யூவை ஆட் பண்ணணும். வர ரீடிங்கோட ஆட் பண்ணிடணும். பிளஸ் வேல்யூல ரீடிங் வந்துச்சுன்னா அந்த வேல்யூவை மைனஸ் பண்ணும். வர ரீடிங் மெஷர்மெண்ட்ல வர ரீடிங்ல மைனஸ் பண்ணும். தென் நெக்ஸ்ட் we can use vernier caliper to find the different dimension of any familiar object. If the length, width and height of the object can be measured, volume can be calculated. For example, if we could measure the inner diameter of the beaker using appropriate jaws as well as its depth using the depth probe, we can calculate its inner volume. So when we enter to the chemistry lab, so many we are having so many beakers, we have to find out the inner side diameter of the beaker. Means we can use the vernier caliper, we can easily find out the inner diameter of a beaker, and then depth of the beaker also calculated with the help of the vernier caliper. The next, the last important thing is digital vernier caliper. Here this picture is indicated digital vernier caliper. We are living in digital world and the digital version of the vernier caliper are available nowadays. So digital vernier caliper as a digital display. Here this is a digital display on the slider which calculates and displays the measured value. The user need not manually calculate the least count, zero error, etc. So we should not calculate manually the zero error and least count. This display automatically shows the zero error correction and the least count value. So we can easily calculate with the help of this digital vernier caliper in the modern world. So once again repeat the statement of least count. Least count is equal to value of one smallest main scale division divided by total number of vernier scale division. Value of one smallest main scale division is nothing but 1 millimeter. Total number of vernier scale division is nothing but totally 10 readings having vernier scale division. So 1 millimeter least count is equal to 1 millimeter divided by 10 is equal to 0.1 millimeter. So the unit converted to millimeter to centimeter, 0.01 centimeter. That means 0.1 divided by 10 is nothing but centimeter. So it's 0.01 centimeter. Next, what is mean by positive error? What is mean by negative error? First of all, we should know about the what is mean by zero error. Check whether the zero marking of the main scale, here zero marking of the main scale coincide with the of the zero of the vernier scale. So two zeroth lines are exactly coincide, means if they coincide then there is no zero error. If they are not, they do not coincide with each other, instrument is said to be possess zero error. There are two kinds of error. One is the positive error and another one is the negative error. What is meant by positive error? If the zeroth of the vernier is shifted, this is the zeroth of the vernier is shifted to the right hand, right of main scale. Right of main scale is called positive error. On the other hand, if the zero of the vernier scale is shift to the left of 0 of the main scale is called as a negative zero error. What is the formula for the positive zero error? Plus 5 into LC plus 5 into 0.01 is equal to 0.05 centimeter. Here, fifth line only exactly coincide with main scale reading. Vernier scale of fifth reading, which is exactly coincide with the main scale reading. So, the error, positive error formula plus 5 into least count plus 5 into 0.01 is equal to 0.05 centimeter. So, this is the error. Correction means is negative. Zero correction is negative. In the value minus பண்ணாதான் இங்க after போனேன் right hand side பண்ண 0 before வரும். So minus 0.05 centimeter. Similarly, negative error formula is so fourth line exactly coincide from the 10th to sixth line is calculate means fourth line minus 4 into LC minus 4 into 0.01 is equal to 0 minus 0.04 centimeter. So 0 error, negative error, 0 error value is this is 0 correction means positive. Positive means minus 1 the value left ல போன value 0.04 add பண்ணியாச்சுன்னா 0 க்கு exactly வந்துரும். அப்போ corrected ஆயிடும். Reading correct ஆயிடும். அதனால தான் 0 correction positive. Hence 0 correction is plus 0.04 centimeter. So very important topic from your first lesson, measurement. So vernier caliper and screw gauge. Thank you very much.